Hello and welcome to your 6.3b problem set key. I've already filled out some of the information for us to speed up this process a little bit, but we have two new similarity theorems. We have SAS and SSS. So just a reminder, the SSS congruence postulate says if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So we proved triangles congruent that way. Similarly, yes, that is a pun, there is also an SSS similarity theorem, and that says if the sides of one triangle are all proportional to the sides of another triangle, then the triangles are similar. So remember, proportional means you just divide them, and if all of those ratios are equal, those fractions are equal, then the triangles are going to be similar. So here's an example. Is triangle ABC similar to XYZ? Now remember, the order matters. So AB and XY correspond to each other, which is already represented over here. BC corresponds to YZ, which is why we have that ratio. And then AC corresponds to XZ. Okay, so we're just going to find those ratios. AB is 4 over XY is 5. BC over YZ is 6 over 7.5, and then we have 8 over 10. And you can use a calculator to show that those are actually all equal. So all three sides have the same ratio, or you can say all three sides are proportional. And again, use a calculator if you want, and you can show that all those are equal. So all three sides are proportional. Therefore, by the SSS similarity theorem, the triangles are similar. Actually, I'll say triangle ABC is similar to triangle XYZ. Remember the symbol right there for similar. Okay. So that's it for SSS similarity. Then we have SAS similarity. Again, let's review the congruence postulate, which is if two sides and the included angle, so remember the angle between the two sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So the similarity theorem says if we have two pairs of sides of two triangles are proportional and the included angles are congruent, then the triangles are similar. So remember, for similar triangles, we have to have congruent angles and proportional sides. So this is just saying, hey, check that two sides are proportional, and if the angle between them is congruent, then we know that the triangles are, in fact, similar. So let's look at this example here. Are these two triangles similar? So we're going to check the ratio of this side and this side compared to this side and this side, and then the angle between them. Now, sometimes we could do this wrong. Like, how do we know? Well, in this case, they tell us that AB and XY are corresponding. So we know it in this problem. But if you didn't know if the triangles were similar already, or which similarity statement we were trying to prove, you might have to check both, like it may be AB over XY. And if that didn't work, maybe you'd try it over XZ. And so you just might have to try both sets of ratios. But here we know which ones are supposed to correspond. We know AB corresponds to XY. So we have length AB over XY is 15 over 10. AC over XZ is 21 over 14. And both of these angles are 75 degrees. So we can show, you can use a calculator, show that those are actually congruent to each other. And so the two pairs of sides are proportional. So our concluding statement, we can say two pairs of sides are proportional. And the included angles are congruent. Therefore, triangle ABC is similar to triangle XYZ. Okay, and that's it. That's the new stuff. So let's go through some problems here. All right, are these triangles similar? If so, what proves it? And if not, why not? So for this one, we're just going to find the ratio of all the side lengths. So I'm going to take, and again, I'm not sure which ones pair up here because we don't have a similarity statement, so we don't know which sides correspond. Now in this one, they kind of look the same. So I'm going to say that maybe 6 corresponds to 4, this side corresponds to that side, and maybe this side corresponds to this side. Okay, might not be right, but let's check it. If it works, then we're good. If it doesn't, then we gotta try other pairs. So I'm gonna do 6 over 4 from the green. Does that equal 9 over 6? And does that equal 10.5 over 7? They do in fact all equal each other. They're all equal to 1.5. So you can just check that with the calculator. So we can just say, yes, they're similar by SSS. Don't need anything formal here. Okay, let's move down to B. Okay, now we have an angle that we know is the same, so we got to check the ratio of the sides between them. So this is what I'm saying, like which side corresponds to what? Is it 7.5 corresponds to 4, or does 7.5 correspond to 6? And you might check it one way and it might be wrong. So I'm actually going to do it the wrong way first just to illustrate what happens. Let's say we think these sides maybe correspond to each other. So we would do 7.5 over 4. Does that equal 6 over 5, or sorry, does that equal 5 over 6? Are those equal? We can figure those out and show that they are in fact not equal. So then we can try it the other way and say, all right, does 7.5 correspond to side length 6 then? And then 5 corresponds to 4. And then we could try 7.5 over 6. Does that equal 5 over 4? And yes, those are equal. You can check that on a calculator. And so yes, these are similar triangles by SAS. Okay, jumping up to C. Now in this one, again, you might need to try more than one way, but I think visually we can kind of tell that this side corresponds to this side. So 10 over 7. Does that equal 9 over 6, like this over that? Or it could potentially need to be 9 over this 4. But we're going to show that they are not equal no matter what. So since those are not equal, they are not similar. Not similar. Okay, and then D. So we have an angle between two sides. So now we can just check 8 and 4.8. I believe you do have to match up the bigger side lengths, actually. So kind of what I said over here on this one when I did it wrong to begin with. I think it was this one I did wrong to begin with. If I match up the bigger side with this one with the bigger side with that one, those have to be the corresponding sides. So that's another way to think about it rather than guess and check. So I'm going to pair 8 with the bigger side here, and then the smaller side 7 with the smaller side here. And that's probably would be a little faster for you guys. So does 8 over 4.8 equal 7 over 4.2? Again, use a calculator. You'll show that those are in fact equal. So yes, by SAS, these are similar. Okay, number 2, let's find the value of x in the picture. Okay, this one's, so we have similar triangles because we have angle, angle, and then angle, same angle there. So we have angle, angle, so they are similar. Now this one's in the small triangle, since this whole length here is 17, and this little length is x, we have to label this as 17 minus x. Okay, and then we're going to show that this over this is equal to this and the whole length divided by each other. So let's take the big length 20 over 15, and that has to equal the big length 17 over 17 minus x. Now we're going to cross multiply. Now when you do the 20 times 17 minus x, you got to distribute. So you can show it like this if you want. And that's going to equal 17 times 35. Or you can just distribute it in one step. You get 340 minus 20x is equal to 255. Again, you're using a calculator for this, no biggie. Subtract 340, and you get negative 85. So x is equal to 4.25. And it's okay to get decimals. Don't worry about that. All right. Number 3, let's find the values of x and y. Now in this, we know these two angles are congruent because of vertical angles. Then if we do this whole thing, now that tells us that these two angles are congruent because they're alternate interior. The other pair is also alternate interior, but also the third angles theorem. Since we already know purple and blue are congruent, then those are congruent. And that's important to know which angles are congruent because that tells us our corresponding sides now. So look how the 7 here is between the green and the blue. So that corresponds to y. So when we set up our proportions, we can say 7 over y. Let's highlight these. So we got 7 corresponding to y because they're both between green and blue. We have 5 between green and purple. So that corresponds to x. And then therefore, these other two sides, 3 and 2, correspond. So now we can do like 7 over y. That would be a 4, not a y. 7 over y is equal to 3 over 2. Cross multiply, and you get 14 equals 3y. So y equals 14 divided by 3, or 14 thirds. You can just leave it like that. And then let's do x over 5. So I did the small triangle first, equals 2 over 3. So make sure from like, if x is on top here, then I need to use the same triangle side on top. So that's why I put 2 on top over here. And now you can cross multiply if you like to do it like that, and you get 3x equals 10, and so x equals 10 thirds. Okay. Moving right along here. Are the triangles below able to be proven similar? And so here we have angle, angle, angle. So yes, by angle, angle. And we can write a similarity statement. Since all the angles are congruent, it doesn't actually matter what order we write. We can say like F, G, H is similar. And we can say any 3 letters. It doesn't even have to go, like I said, F, G, H. I don't have to go Q, R, S because all the angles are congruent. But I will just write it in the same order anyway. So Q, R, S. Okay. Number 5 are the triangles. So same question every time. So I've already redrawn these triangles and kind of separated them for you. And then this is one where you want to take like the biggest length with the biggest length. So we have biggest length here needs to correspond to biggest length here. Second biggest length, which on this triangle is 12, has to correspond to 16, the second biggest length there. And then the smallest has to correspond to the smallest. So we're going to check those ratios, those proportions, and see if they're the same. So we can do 15 over 20. Does that equal 9 over 12? Which does that equal 12 over 16? And you can simplify all those yourself, or you can use a calculator to figure it out, but they are in fact similar. These all equal 3/4. So yes, they're similar. And we used SSS. And our similarity statement then is triangle, let's say XZW is similar. So I said XZW, and then that has to be similar to YZX. Okay, and you can check the similarity and just make sure that these corresponding sides match up correctly. Like XZ should correspond to YZ, ZW corresponds to ZX. So that's how you know which similarity statements are right. Number 6. Okay, we just have 3 sides here, so let's again do biggest side over biggest side. Does that equal smallest side over smallest side? Does that equal medium side over medium side? So let's test that out. We have 39 over 26. Does that equal 36 over 24? And does that equal 30 over 20? And they all equal 3/2 or 1.5. So they are, in fact, congruent. So yes, this is SSS. We used all 3 sides. And so our similarity statement here would be triangle LMN is similar to triangle YZX. So LM, so I wrote LM first, which corresponds to YZ. So that's why the similarity statement is like that. Number 7, are these triangles congruent or similar? Sorry. Are they similar? So let's find missing angles. We have 32 and 90. This is also 90 on this side. So we have 58 and 90. That means this has to be 58, and this has to be 32. Okay, and so we've shown that 2 angles are congruent, really all 3, and so they are therefore similar by angle, angle, and we can write a similarity statement. Triangle CFD is similar to triangle DFE. Again, just make sure corresponding sides. So like D is the 32-degree angle, so I had to put C, the other 32-degree angle, in the same spot over here in my similarity statements. All right, last problem. Are these similar? Well, it looks like we have SAS. So let's just check corresponding sides. We got 24, the smaller side and the smaller side, and the bigger side and the bigger side. So does 28 over 21 equal 24 over 18? And those are, in fact, both equal to 4/3. And then we have the angle between them. The angles between them are equal because they're both 90. So yes, because of SAS, and our similarity statement would be triangle SRT is similar to triangle PNQ. And that's it. Hope you learned a lot.